This short tutorial will show you how to use Slicer, which is an Autodesk program that helps you convert a digital model into a physical model. You should go ahead and export your Rhino file as either a .stl or a .obj. I would try both settings and see what gives you the best result in Slicer. By default, you'll notice here that the up axis is set to Y, so whenever you import your Rhino model, you probably want to switch that so that the Z axis faces up, or else your model will be rotated in 3D space. For this tutorial, I'm going to use one of the default sample files, which is this hanging lampshade, as you can see here. When you start Slicer, there's a bunch of tool palettes along the left-hand side. What's great about this is it's kind of a checklist for the order in which you should work through the software. So the first thing we do is import our model. The next thing we want to do is set our manufacturing settings. This is where we set the material that we'll be using to make the physical model. So go ahead and hit the little pencil icon in this setting and you'll see a new dialog box pop up. There are a bunch of preset materials here at 0.1772 inches. This is a little more than 1/8 of an inch thick, and so you'll have to determine by using a caliper. You'll have to measure the thickness of the material. You don't want to just read the thickness off of the sticker or off of the packaging. You want to get a really accurate measurement. If you don't do that, the scale could become distorted when you make the model, or you might have difficulty getting the pieces to fit together. So for your purposes, we're imagining that you're probably going to use paper, Bristol board, or a thin cardstock, and that those might be 8.5 by 11 or 11 by 17 pieces. So I'm going to go ahead and start with the 8.5 by 11. I'll duplicate that material and come over and create a new material. So here I'll make this 11 by 17. And again, I would want to use a caliper to determine the thickness, but if it was Bristol, it might be somewhere in the 0.05 inch range. I can leave a bit of a margin. And then here in the slot offset, for some of the model types, such as a waffle, you might ask it to cut a type of joint where you can slip one sheet of paper or one sheet of material into another material. So this is a case where, again, you would need to know exactly what your thickness is and then add a little bit of width to that so that you don't have a zero tolerance fit. In this case, that takes some trial and error, so I might want to add one more zero to the front of this and give that a try. Okay, and so then I will say done. Make sure I select my new material. I should probably give it a better name than that. Okay, and I'm ready to move down the list to the next thing. The next area that comes up in our to-do list is the object size. Here you want to make sure that your units are set to the exact same units that you were working in Rhino. So if you were working in feet in Rhino, make sure you switch this to feet. And then really what you would like to do is check the dimensions and make sure that these dimensions match the dimensions that you're expecting. Before you export your model from Rhino, you should scale it to the real life size that you would like to make the model. So this, before you export from Rhino, instead of working at 1 inch equals 1 inch, you would scale to, say for example, 1/8 of an inch equals a foot, and then determine exactly how big your model would be. Maybe it's going to be something like 2.5 inches tall, and you would just want to confirm that these dimensions are correct. The next window here is the construction technique. Slicer has built in a few different types of techniques. Stacked slices is what we sometimes refer to as a pancake model. So this is where, those are very thin, but that's because the material that I chose was just paper. So you can see if you made this out of paper, that you would end up with 173 sheets of 11 by 17 paper, 502 parts, and we're just getting very thin stacks. To better illustrate this, let me show you a thicker material. There we go. So now you can see what the pancaked model or the stacked slices would look like. So in this case, I'm going to cut a whole bunch of rings, and there's a blue line that's showing me the edge where I would cut, and then a red line which helps me to line up the piece above. So in this case, I would have 31 sheets or 42 parts, and this is potentially easier to assemble, especially if my material is thicker like cardboard or coroplast. Although cutting perfectly round shapes out of cardboard or coroplast by hand might be difficult. When you're working in the stacked slices and in the interlocking slices, you have some other options about the slice direction. So this interface is a little bit tricky to get that quite right, but now you can see that I'm turning out to have elliptical shapes, and I'm cutting this at a different angle, which gives a very different effect. Other options that you might be interested in is interlocked slices. This is what we often refer to as a waffle model. And also folded panels could be a good option, and in this case I would like to go back to my thinnest material, something more like paper, and so this is where it's going to try to show you how to fold paper, cut and fold paper, so that you could refold the paper back together in order to create this three-dimensional form. And then we'll spend a little more time looking at the folded panels option. When you select folded panels, you'll get a preview window that shows blue cells and red cells. If you're seeing red on the model, that means that those are surfaces that have errors in them. Oftentimes, the error is actually that the piece is too big to fit on the piece of paper. So over here we're getting a preview of what this part would look like on our sheet of 8.5 by 11 or 11 by 17 paper, and it's showing that the tail of that part actually goes off of the page. So there are a couple of things we can do to get it to the point where the entire model would be blue and we don't have any red. One of the things we can do is just increase the vertex count. You'll see in that case I ended up with more red. Sometimes this will solve your problem. I'm going to go ahead and take this up to 250. The more vertices you have, the more accurate your final form will be to the original shape. But since you guys will be making these models by hand, you're hand cutting the pieces and hand folding the pieces, every time you add more vertices, that's more folds that you'll have to make by hand and more pieces that you'll be cutting. So you want to find the right balance. One thing that you should also do, and it might be good to do this before you add and remove all of the seams, is to select your joint type. You're going to need something to put glue on in order to glue all of these edges together. Each one of these polygons will be cut out as a separate piece of paper with folds along all of those lighter lines, and then you need to glue that piece of paper to this piece of paper. For example, piece 27 will attach to piece 7, so we need a little tab to glue to. Here, this gives you your options for tab type. Should it be diamond-shaped, gear-shaped, lace? There's even a tab where you can fit it into a little slot, or here I have selected the tongue option. There's a tool here where you can add and remove seams. This gives you an opportunity to manually make some of these pieces smaller. So I could simply add a seam here. Let me try. Okay, now it turned bold. and hit the Done button, well, I'm still seeing red. So I would keep trying to work through this. Let me add another one here. Okay, I got that one. How about another here? And you would basically work through this process until you got the entire model to look blue. So after working at this for a few minutes using the Add Remove Seam button, and then after each adding and removing, hitting the Done button so that it updates the preview, I now have the model so that there are all blue cells all the way around. So once you're finished with that, we're down to the bottom of our to-do list. This is a piece that could now be made. You can hit the Get Plans button. This is showing us that it's going to take 5 sheets of paper, and you can actually save these plans here. It gives you the file type, so I would save it as a DXF or a PDF, but a DXF is better because you can take it into Rhino and continue to work at it to scale. Keep your scale in the same units that you've been working at all along. Export this file, and you can actually take this into Rhino, and you could potentially do an even better job of nesting the pieces together so that you could fit them on fewer pieces. So I could take these parts in Rhino and move those pieces and sort of fit them in, rotate them in, and fit them into this white space so that I could just print these 4 sheets, and then I would use those 4 sheets to cut. You should notice that we will get a dark blue outline, which that's the line that you would cut. We're getting this gray dashed line, that's where you should fold. We'll get the number printed, so that'll show us which pieces go together. And then there are some numbers that will be printed on each tab that will make it so that you know how to fit them together. This looks like a pretty complex model to me, all of these pieces to assemble by hand. So maybe for your first one you might want to go back and have fewer polygons so that you can get the feel for it.